Hello everyone, I am Deepali Jadhav working as an assistant professor in Electronics and Telecommunication Department of College of Engineering, Fulton. Today we will see the practical to study different types of sampling and its reconstruction under the course Analog Communication. So before that, first of all, what is sampling? Sampling is the process of converting continuous time signal into discrete time signal, and to convert this continuous time signal into discrete signal, we have to follow the sampling theorem. That theorem states that fs, that is sampling frequency, should be greater than or equal to twice of fm. Here in the diagram you can show that this blue color shows the analog input signal and red color is the sample signal. So this is the process of sampling, where sampler combines these two signals or multiplies these two signals to get the sampling signal S of t. There are three types of sampling: ideal sampling, natural sampling and flat top sampling. Ideal sampling is nothing but the analog signal will get multiply with the periodic pulse train as shown in the figure, and the output will have the only some instance of analog signal as shown in the figure, ideally sampled signal. This is the natural sampling signal. So in this, analog signal will get multiply with the periodic pulse train C of t as shown in the figure. You will get the output. This circuitry will be very similar to the switch circuitry, means this signal will be passed from the switch, which will have the on and off times like this periodic pulse train, and you will get the output as shown in the figure. So we will see the natural sampling in the practical session also. And this is the flat top sampling. Here top of the analog signal, sample signal, will be flat, means here sample and hold circuitry is used. We will see in part A natural sampling and in part B flat top sampling. Now this is the circuit for sampling and reconstruction. So this part shows the crystal clock, and this is the control circuitry to generate A, B, C signals. A is used for natural sampling. This is the circuitry for natural sampling, and B and C are used for the flat top sampling circuitry as a control signal. Then this is the receiver part. Here we can reconstruct both signals, flat top sample or natural sample signal, and here ground pin is there. After reconstruction of sample signal, this signal will have some distortions. To remove these distortions, we have to use this low pass filter. Now we will see the natural sampling connections. Now we will switch on this switch, then connect crystal clock to the control clock. Then for natural sampling, we have to use this A as a sampling clock. This will be connected to the sampling clock of natural circuitry. Then next we have to connect the input signal. We are going to consider frequency divider output as an input signal. We can connect this generated output also. So this is connected as an input to the natural sample circuitry. Now we can observe the naturally sample signal at the output. We will connect this pin to the CRO. I have connected channel 1 to the input of sampling signal and channel 2 to the output of natural sampling, and both ground pins are connected to the ground pin. We will observe the waveform, sample waveform and analog signal both simultaneously on the DSO. This yellow color shows input signal, analog signal, and this is the sample signal. We can check this signal. We can measure the frequency amplitude. Here I have measured directly peak to peak amplitude of both signals and frequency. These two frequencies and amplitudes are approximately same. So this is the natural sample signal. Now we will see the reconstruction of this signal. Now for reconstruction, we have to connect this sample signal to the input of receiver. Then we have to connect sampling clock A to the whole pulse, and then one capacitor we have to connect in the circuit, either C1 or C2. I am connecting here C1 capacitor. Now we can observe the reconstructed signal on channel number 2. Channel number 1 connected to analog input and 2 is connected to the reconstructed signal. We can observe the waveforms on DSO. You can see that this reconstructed signal having some distortion. So to remove this distortion, again we have to connect this output of reconstructed signal to the low pass filter input. So I am connecting here input of low pass filter. Then I will observe output of low pass filter. Now this will be the perfectly sample signal on DSO. This green color shows the reconstructed signal, which is having approximately same peak to peak amplitude and frequency as that of the analog signal, and some we can observe here reconstructed signal is somewhat delayed but reconstructed properly. So this is the natural sampling. Now we will see the flat top sampling. For that again we have to connect this crystal clock to the control clock input. Now for the flat top sampling we should connect this B input to the sampling clock. Then input frequency divider output, that will be considered as an input for the flat top sampling, and this B control signal will start the sampling and it will hold the output till this dump clock. So we have to connect this C control pin to the dump clock. Now we can observe the input and output simultaneously on the DSO. I will connect this channel number 1 to the input of sampling signal and output to the channel number 2, that is flat top sampling. Now we will observe the waveforms on DSO. These two waveforms shows, this is the input waveform sampling signal and this is the sample signal. You can observe the top of the sample signals is flat, and we can measure with the help of measure knob frequency and peak to peak amplitude of both signals. It seems look like. Now we will see the reconstruction. For that we have to connect output of flat top sample signal to the input of reconstruction circuitry. Then we have to connect whole pulse to the B input. Then we have to connect one capacitor. I am connecting here C1. Now we can observe I have connected pin number 1, channel number 1 to the input. Now I will connect output of receiver to the channel number 2. Now we will see the waveforms. We can see that this is the reconstructed signal. Here reconstructed signal is having some distortion. So again we have to pass this signal from the low pass filter. Here I am connecting output of reconstructed circuitry to the low pass filter input, and I will observe the output of low pass filter with respect to input signal on the DSO. Now we can see that yellow color waveform shows the input to the sampling signal and this green color signal shows the reconstructed output after filtering, and these two signals are having the same frequency, approximately same frequency and peak to peak amplitude, and some delayed output will be there due to some hardware delay.